Hello, I'm Papia. In this problem, we are going to compute the volume of a solid region. So in this problem, we have this equation given to us, z equals 5 minus x minus y. It represents a plane. And we have to compute the volume of the region that's bounded by this plane in the first octant. Okay, so let's recall how to compute volume. You know that volume can be computed using integrals. In this case, it's a solid region, so we'll use double integral over the region R in the xy plane. And here we will have the area of the base times the height. Now the height is given by f of xy, and area of the base is dA. So this is the setup. Now look at the function that's given to you. It's already written in an explicit form, and so the function of xy is 5 minus x minus y. So we can immediately plug that in. And dA, you know that it can be either dx dy, or it can be dy dx. Okay, so we will choose that accordingly. So let's understand what this plane looked like and what this region is over which we have to integrate, and then we'll set it up and we'll solve the integral. So go back to our equation for the plane, and in order to graph that, let's rewrite it a little bit. So bring all the variables x and y on the left hand side. So you will have x plus y plus z equals to 5. And then we can try to find the intercepts on the x, y, and z axis. And how do we do that? Well, you can plug in, let's see, you can plug in 0 for x and 0 for y, and then z will be equal to 5. So that's one of the intercepts. And you can do the same for the other two. You can plug in x equals 0 and z equals 0. That will give you y equals 5. And last one, you can plug in y and z both 0, and x will be 5 as well. So those are our intercepts. So you can just come here, plot those 3 points, and then join them, and you will see the plane. Okay, so let's do that. So we need 0, 0, 5, and then 0, 5, 0. So say here is 5 on the y, and just roughly, say here is 5 on the x. So you join all the intercepts. There we go. So that's the plane. And we have to compute the volume of the solid region that's bounded by the plane in the first octant. Okay, so as you see that we definitely need to figure out the region R over which we have to integrate. And this region is basically the trace of the plane on the xy plane, right? So you can see right away on the xy plane, the region is right here. This is R. Well, we have to find the bounds for x and y using that region. So in order to understand that, let's plot the region in the xy plane. Just look at the region R and figure out what are the x bounds and what are the y bounds. Okay, so here's our region. How do we graph this, right? Well, let's see. The region is bounded by x-axis. This is our x-axis. Y-axis, here is y, and this line, right? And the line passes through 5 and 5. So let's draw the line through 5, 0 and 0, 5. Do you see that this region R is exactly that region? Pretty obvious, right? Okay, so we have to figure out what are the x and y bounds. So let's choose x to be the outer bound. You can choose other way if you want. Now, if I want x to be my outer bound, draw the rectangle vertically, okay? Then the width of the rectangle, that is dx, okay? So what is the bound for x? You just look on the x-axis, see, look at the region. Between which two values of x do we see the region? Well, definitely x lies between 0 and 5. All right, now you have to figure out the y bounds, right? Now y will be determined by the length of this rectangle. So what are the bounds? Obviously, you see that all the rectangles, the lower bound will be 0 for y. And what is the upper bound? Well, the top of the rectangle is touching the line, so it will be the line. Okay, what is the equation of this line? Well, one way to figure it out is look at our original equation of the plane, and we want to figure out its trace on the xy plane. So just plug in z equals 0. So if you have z equals 0, what do you get? We get x plus y is equal to 5. That's the line. And so solve for y. Y is 5 minus x. That's exactly the upper bound for y. Okay, so this is our region R, and these are the bounds. So come back to our integral, plug them in. Remember, we want x to be the outer bound. So dx is on the outside, so the outer integral will have the x values from 0 to 5. And dy, that's the inner one. So in the inner integral, we will have 0 to 5 minus x. And we already know that the function is 5 minus x minus y. So this is the setup. You solve the integral, you will find the volume. All right. So to solve it, let's ignore the outer integral first. Let's only concentrate the inner one and see it's in terms of y. And so x is a constant in this case. All right. So 5 minus x, this entire expression is constant with respect to y. So we keep the 5 minus x as it is. And what is the antiderivative of 1 dy? Just y. And then the next term is minus y, so its antiderivative is minus y square over 2. And then you have to plug in the y values from 0 to 5 minus x. And we'll have dx. Okay. Let's plug in 5 minus x for y. So the first term, you get 5 minus x times 5 minus x. So it's 5 minus x square. Minus, next term is also cy square. So you have 5 minus x square over 2. All right, just simplify this term. See, you can take out a common factor of 5 minus x square. You will be left with 1 minus 1/2. So this is just 1/2 of 5 minus x square dx. All right, single integral again. You know exactly how to solve this. Find antiderivative, use fundamental theorem, and you're done. So take out 1/2, and then what is the antiderivative of 5 minus x square? You can do a little use substitution, and you will actually use the power rule. So 5 minus x cubed over 3. But see, x has the negative sign, and you know when you do the u sub, you will get a negative sign in the front as well. So that is antiderivative. All right, so we're almost there. Let's plug in the value. So the constant is 1/2 times 1 over negative 3, so negative 1/6. And then when you plug in 5 for x, is 5 minus 5, so you get a 0 cube. And then when you plug in 0, you get 5 cube here. There you go. So a negative and a negative makes it a positive, 0 goes away. Answer is 5 cube over 6, or 125 over 6. So 125 over 6 cubic unit is the volume of the solid region bounded by the plane in the first octant. Thank you.